Okay, so now in this presentation I would like to explain about the division multiplication of 8 numbers and the division of 2 8 numbers. So these are the programs. This is the multiplication program. So here in the 8085 instruction set there is no instruction to performing of a multiplication process. So therefore the instructions are there in the instruction set of an 8085 microprocessor. So those all are the addition, subtraction. Okay, so but there is no instructions for the multiplication and the division operation. So that's why we have to implement a logic to performing of the multiplication and a division. So the first of all we will consider the multiplication operation, and that for this purpose we have to implement one logic. So here logic for multiplication. Logic for a multiplication. So actually I consider a number here. So for example, consider a number that is 5 cross 4. So that is nothing but the multiplication. So 5 cross 4 is equal to, it is a number 13. Actually, so there is no instruction to performing of the multiplication in the 8085 instruction set. So therefore we have to modify this multiplication into some other operation. So for example, if we add 1, 2, 3 and 4, 5 plus 5 10, 10 plus 5 15 and 15 plus 5 20. So that means this 5 is adding 4 times, then we will get the result. Okay, so and we will consider a number that is 4. 4 plus 1, 2, 3 and 4. So 4 plus 4 is 8. So 8 plus 4 is 12. 12 plus 4 is 16 and 16 plus 4 is 20. That means if we add the 4 in 5 times, then we will get the 20 as a result. So that means this is the logic we will use to implement the multiplication of two 8-bit numbers. Okay, for this purpose I consider a number that is 3 into 4. So that is 12. Okay, so 12 is nothing but here 3 plus 3 plus 3 plus 3, that is nothing but in 4 times we will add the 3, I will get the number 12. So for example, if I consider 4, so here the 4 plus 4 is added in 3 times, I will get the 12 here. So now I use the same logic to draw this multiplication of two 8-bit numbers. So these programs are very easy programs. Okay, so the first of all here any register, any data we consider. So first of all that data is loaded with our registers. That is the first step here. Okay, so here this is the instruction is LXI. This is LXI instruction is nothing but whenever the X is mentioning in the instruction, so therefore this instruction is belongs to the register pair instructions. In our 8085 instructions there are a pair of instructions are there. Those instructions are HL pair, BC pair and DE pair. So these are the instructions. When the X is mentioned in the instruction, so therefore this complete instruction is belongs to a pair of registers. Okay, so here the first instruction is XI, LXI, H. So that is nothing but this instruction is belongs to HL register pair here. So that means, so what is the meaning of this instruction? So here this is also an hexadecimal value. So what is the meaning of this instruction? So what is the address is there. So in this address, what are the data is there, those data is copied or moved or loaded to this HL register pair. Okay, so I am mentioning here, I am mentioning X here. So this instruction is belongs to HL register pair. Instead of this H, we have to use either B, C, D, E. So whatever it may be. Okay, so this is the meaning of this first instruction. Now we will go to move A comma B here. So that means what? So what are the values are there in this accumulator? So those values are copied to this B register. Okay, so the next one is increment H here. So actually, so for example, I consider the data. So here this is a memory location. So this memory location is indicating the HL register pair. So that memory is starting with 0, 1, 0, 0, H here. Okay, so whatever the data is there in this data is saved in the HL register pair. Okay, next one is I consider move B comma A here. So that means whatever the data is there in the A register, those data is moved to this B register. And next one is increment. So this is INX X here. So what X is nothing but we have to increment the that means pair of registers. Here also we have to use DE pair, HL pair and BC pair. So but increment X is nothing but we have to use here only HL register pair here. So therefore INX is nothing but this HL register pair is incrementing. So that means it will incrementing to the next state. So that is 0, 1, 0, 1 H here. Okay. So and next one is move C comma M here. So that means whatever the memory is there in this location, so that memory address is moved to this C register. Okay. So next one is immediate an address. That means we have to initialize an accumulator with 0, 0 H here. Okay, so therefore after I is nothing but an immediate data. So here this is also immediate data. So therefore we have to mention data directly at this instruction. Okay. So after execution of this instruction, A is equal to 0, 0 H here. Okay. So now add B here. So what are the value is there in this B register? So this value is add to this accumulator. So for example, initially, so the value in this register is I consider 0, 3 here. Okay. So that means whatever the A is there, that copied to this B register. Therefore here B is equal to, that means here B is equal to 3 here. Okay. So therefore add B here. That is, what is the meaning of this instruction? So here add A with B and the result is stored in the accumulator. So here the result is 0, 0 plus 0, 3. The result is 3 here. Okay. So now the decrement C here. Here now mentioning the C here. That means what is the meaning is that means here I consider 3 plus 3 plus 3 plus 3 plus 3. That means 3 plus 3 is 6. 6 plus 3 is 9. So 9 plus 3 is 12. That means, so what I am considering is, that means 1, 2, 3, 4. That is 3 cross 4. That is 12. So that means 1, 2, 3, 4 times. Okay. So the first one is completed. That means first 0 plus first condition. So 0 plus 3 is completed. So the result is 0, 3. And the next one is here actually C is equal to Actually C is equal to 0, 4 here. Okay, so that means why? So 1, 2, 3, 4, that means the 4 times the 3 will add. Okay, so actually that is C is equal to 0, 4 here. That means decrement C is nothing but it will minus 1, that means it will reduces to 3, that means 1, 2, 3. How many operations that can perform? 3 operations they can perform. Okay, so therefore J and Z is nothing but jump, no, non-zero. So therefore this is non-zero, therefore you have to go to this top position. Okay, then we have to again add B, that is nothing but an accumulator having a 0, 3 here, and again add B is nothing but, so here add 0, 3 plus 0, 3 here. So therefore the number is 0, 6. Okay, so and again decrementing of this 4. So this is completed and this after this, that means 4 is completed, 3 is completed and 2 is completed. 3 is completed, 4 is completed, 2 is completed. So again decrement. Then J and Z, that means non-zero. Therefore this is not 0. Therefore they will jump to top here and again add this accumulator with B. So an accumulator is equal to 6 here, add B is nothing but B is equal to 0, 6, 0, 3 here. Therefore A is equal to 0, 9 here. So and after that again decrement C here. Okay, so decrement C is nothing but it will 4 is completed, 3 is completed, 2 is completed, and after last one, that is 1. Okay, so therefore it will be decrementing J and Z top. So therefore non-zero we have to jump, and next one is we will add again 0, 3 here. Therefore the finally the answer is 0. Okay, therefore it will be 0. So we will increment HL register pair. So therefore HL register is there, we will increment HL register pair. So why? Because we have to save the result in the accumulator to this memory location. So therefore I use an instruction move M comma A. So here A having a 12. This 12 is moved to this memory location. So this memory location, the 12 is saved here. Okay, so and after that it is halt. Okay, so simply, so this is the multiplication of two 8-bit numbers. So here this part is very important part. This declaration is the program can anyone in many number of ways you have to write this program. Okay, so but this part is very important. So depending upon this logic, the multiplication process is implemented. So now we will move to the division operation. So here in this division also there is no specific logic or specific instruction to perform the division operation. So therefore in this division operation also we have to implement the logic. So what is the logic for this multiplication? So for example I consider a number that is 8 by 3. So that is nothing but the division operation. Okay, so after performing of a division operation, so it will produces some carry. Okay, so then if when the carry is generated, so then it will goes to the next bit position. So that means for performing of division operation in the 8085 multiplexer, so it can use a one logic, so that is the subtraction logic. Okay, so for the subtraction logic, so 8 minus 3, that is equal to 5 here. If a carry is generated, then it will add. Okay, so again and subtract again 5 minus 3, that is equal to 2 here. Okay, and again if the carry is generated, again subtract with 2 minus 3. So here this is a minus 1 is generating. So whenever this minus 1 is generating, then it will compare with the resistors, and the result is stored in the accumulators. So now I will explain about this program. Okay, so here MVI is nothing but, so this is move immediate data. So immediate data is nothing but after the operand you have to directly mention the data here. Okay, so whatever the data is there, so this data is moved to this C. So C here using for the counting purpose. Okay, so and next one is MVI IA comma data. So here this is also directly use the data. So for example, in this place data is equal to some 80H I think. Okay, so this data is moved to this accumulator, that is 08. And next one is MVI, move immediate data to B. I consider a number that is 03 here. Okay, so then it will compare the B. So what is the meaning of this instruction? So in accumulator, what are the contents are there? Those contents are compared with the contents are stored in the B register. So the contents are stored in the B register is 3. The contents are stored in the A register is 08. So it will compare these two. So how it will be compared? So A less than B, or A greater than B, or A is equal to B. So likewise this instruction will compare A and B. Okay, so next come to jump carry. So if the carry is generating, subtract B here. So there is a carry is generated. So that means this is A and this is B. So subtract B is nothing but 3. So whatever the A value is there, those A value is subtract with B. Okay, so and next one is increment C. That means the count, first of all it is 0 0. After increment C it is from 0 1. Okay, and next one is again compare B. Again compare B. So again mali A greater than B, A less than B, or A is equal to B. So likewise it will compare. Okay, so and after that if in case a carry is generated, and again go to the loop and it will subtract the B and increment C and again compare. So that means this loop is repeating. So here this loop is repeating. If in case no carry is generating, therefore the result of the count is stored in the accumulator. Okay, so therefore after an accumulator is stored with an address location of 5751. Okay, this is an optional address location. You have to take any address location. So therefore after completion of a program, you have to write the halt instruction. So HLT is nothing but halt. Okay, so halt is nothing but the program is stopped now. Okay, so these are the two programs for 8-bit multiplication and 8-bit division. Okay, so these two are the very simple programs, but the logic is very important. Now I will explain about the largest and smallest numbers of an 8085 microprocessor. Okay, so now so here this is the largest number. So here this is MVI is nothing but move immediate data to C here. So this C is also used for, this is accounting purpose here. Okay, so what are the data? So he is nothing but 10, that is nothing but you have to compare the data of 10 bytes of a data. Okay, so now MVIC is nothing but the 10 bytes of data is moved to this C register. Okay, so the meaning of this instruction is, so 0, that means 10 bytes of 10 bytes of data in the C register. And the next one is LXI, that is nothing but load and register pairs. Okay, so that means whatever the address is there, so this address is stored in the HL register pair. So that means we have to use another instruction. The HL register pair is indicating to the memory. Memory is nothing but an HL register pair. So therefore whatever the data is there in this HL register pair, so this data of is moved to an accumulator. Okay, so that means the data is stored in the HL register pair. So for example, the data is some 12. So this data, that means here this HL register pair is nothing but it will indicating some memory location. So that is some 45001 for example. Okay, so that means in this memory location, so whatever the data is there, so this data is moved to this accumulator. After execution of this instruction, an accumulator is equal to 12H. So that means that is the meaning of this instruction. Next, compare memory. So that means comparison operation is performed with an accumulator and the memory. So that means whatever the data is there in this memory location, so this memory location is compared with the an accumulator. Okay, so then jump no carry. So that means no carry is generated, therefore skip this instruction and move A comma M. That means whatever the data is there in this M memory location, this M is moved to A here. So the next one is increment H. So that is nothing but, so here this is HL register pair and the next one we will increment the next location here. Okay, and after that JNC 0. So actually initially this is 10 bytes, the increment is nothing but it is some 9 bytes. Okay, so and after that jump no carry. So if no carry is generated, then again move to this loop here. Okay, and then compare this memory with an accumulator number. Okay, so a memory and this accumulator number. So if in case no carry is generated, skip this instruction and the data is moved in this A register. Okay, so repeat this process. Okay, so then the final result is stored in the STA, that is nothing but store accumulator. So it having of a memory address, that is 4510. So in this 4510 the address is loaded in the accumulator register. So therefore HLT is nothing but halt operation. So for example, for understanding purpose, so I consider a number that is from 63, 32, so like some number that is 12. Okay, so here first of all it will compare these two numbers, that is an accumulator number and the memory loaded number. So the which one is a greater value, so that means there is no carry is generated, therefore this number is filled with an accumulator, therefore an accumulator is equal to 63. Okay, so and after that decreasing of C. So next one is the count is decreasing. So then compare these 63 with this 12. Okay, so when which one is bigger, there is no carry is generated, therefore directly this accumulator value is this 63 is stored in the accumulator. Okay, so the finally, so this is the largest value, then this value is stored in the accumulator, so in the corresponding address of 4510H. Okay, so after completion of this program, last we have to write HLT. HLT is nothing but halt, therefore we have to stop the program here. Okay, so now we will move to the smallest number here. So the both are the same logic deck form, but there is a difference is here we use a jump carry, they are use jump no carry, okay, non carry. So now this is also similar program for the largest number. So here this is MVI 0A comma H, so that is nothing but here also there a C. Okay, so that is nothing but whatever the data is there, that means 0A is nothing but it is a 10 byte of a data. So this 10 byte of a data is copied to this SC register. Okay, so now LXI is nothing but, so here this I use an H here. Okay, so that means the HL register pair having an address of 4500. Okay, so next one is move A comma B is nothing but in this HL register pair is nothing but it will indicating of a memory location. So whatever the data is there in this memory location, so that data is copied to accumulator. Okay, so and then increment M. So memory is incrementing. So here the first of all, so the initial memory is 4500H here, and after that incrementing this memory. So then compare M. So what is the meaning of this instruction? So it will compare A with memory. So that is nothing but A greater than M or A less than M or A is equal to M. So comparison is also called as a subtraction operation. Okay, so when it will perform the comparison with memory, jump carry. So if in case any carry is generated, it will skip this instruction and move this memory whatever that data is there in this memory location. So that data is copied to this an accumulator. Okay, so and after that decrement, see here, that means initially 10 bytes of data is there. So decrement is nothing but this is 0, 9. So next one is jump non-zero. So therefore if there is a non-zero is occur, the loop will be repeating here. Okay, so the loop will be repeating here and again increment M and compare with M to this accumulator. So if non-carry is generated, so therefore the data is stored in this accumulator. Okay, so next again decrement C. So likewise this loop is repeating until the smallest number is identifying. Okay, so and after that whatever the data is there, so that data is stored in an accumulator. So that is STA 4600H. Okay, so in this 4600H the data will be stored. Okay, now finally HLT is nothing but the halt instruction. Okay, halt is nothing but stop the program.